So in this question, we're given this circuit here, and we've got three resistors connected to a voltage source V with no internal resistance. So let's look at the first part of the question. Okay, so we have these statements, and we need to state which one is true. So statement A, the current through resistance R1 and R2 are the same. This is obviously wrong, because if we have the current I1 here, then it's going to split into two different components, I2 and I3, such that the sum of I2 and I3 equals I1. Okay, the currents through resistors R1 and R3 are the same. By the same argument here, this is obviously wrong. So this is A is wrong, B is wrong. The currents through resistance R2 and R3 are the same. This is also wrong, because the only way they would be the same is if R2 and R3 are the same, but they have different values, so this is wrong. How about the voltage across R1 and R2 are the same? This is also wrong, because voltage will be divided according to the values of the resistance of this bit and the resistance of this whole bit there. What we can say though is that R2, the voltage V across R2, equals to the voltage across R3. So this is wrong. So similarly, the voltage across R1 and R3 is wrong, and the voltage across resistance R2 and R3 are the same. So this one is right, and our answer is F. Let's move on to the next part. Okay, so in this part of the question, we need to find an expression for the current through this voltage source. So this is just simply, what we could do is we could just use V equals IR and find the total resistance of the circuit and get that the current is just V over the total resistance. So let's go ahead and work out the total resistance. So we've got two bits, so we've got this bit here and this section here. Those two are in series, so we've got to add them together. So let's work out this bit first. So 1 over the resistance of this bit, which I'll call R prime, equals to 1 over R2 plus 1 over R3. This is just our standard resistors in parallel formula. So this tells us that R prime is equal to, so it's going to be R3 plus R2 over R2, R3, and always to the power minus 1. So this is R2, R3 divided by R3 plus R2. Okay, so this is the resistance of this bit. Now we need to add it with the resistance R1. So the R total here is going to be R2, R3 over R3 plus R2 plus R1. Now let's put everything under common denominator. So this is equal to R2, R3 plus R1, R3 plus R2, R1. The whole thing divided by R3 plus R2. So now to find the total current, as we recall, we need to use this expression here. So we're just going to take V and divide by that. So V over RT is just going to be V times R3 plus R2 divided by R2, R3 plus R1, R3 plus R2, R1. Okay, so this is the expression we got. Now let's just check our options. So we see that this option here corresponds to option A, so this is our answer. Let's now move to the next part of the question. So now in this question, now what we do is we replace R2 by R1. So R1 and R2 now have the same resistance. Let's forget about the fact this is just 1. Okay. Now we need to find the power dissipated in R3. Okay, so I think the previous part might be useful, so let's bring it back here. Okay, so this is the previous part. Let's now plug in R1 equals R2 in this. So now we get this expression as our current. Okay, so we can now work out the current through R1, the voltage through R1, sorry. So the voltage through R1 is just going to be I times R1. So this is just going to be V into R1 plus R3, plus R3 divided by R1 squared plus 2R1 R3, and the whole thing multiplied by R1. So we can divide through by R1. This is just V R1 plus R3 divided by R1 plus 2R3. Okay, so we now have an expression for the voltage across this resistor here. So what is the voltage across this section here. Well, we know that the voltage across this plus the voltage across R1 must be equal to V. Therefore, the voltage across this bit is just going to be the difference in V and the resistance across and the voltage across R1. So V across R3 is going to be V minus VR1. So let's go ahead and evaluate this. So this is equal to V minus V into R1 plus R3 divided by R1 plus 2R3. This is equal to, so we factor out the V, this is just 1 minus R1 plus R3 divided by R1 plus 2R3. Put everything under common denominators we get, so we're going to get an R1 plus 2R3 here, minus R1 minus R3, so it's just going to leave us with R3. So it's going to be R3 over R1 plus 2R3. Okay, so this is the voltage across this resistor here. Now, what is power dissipated? So what we want to use now is power equals to the voltage across R3 squared divided by the resistance of R3. Okay, so let's go ahead and evaluate that. So this is just going to be V squared R3 squared divided by R1 plus 2R3 squared, and the whole thing divided by R3. So this is just V squared R3 divided by R1 plus 2R3 squared. Let's now check our answers. We see that the option we're looking for is option D, so this is our answer. Let's move on to the next part now. Okay, so in the last part, we need to find, for the case R1 equals R2, which of the following values of R3 maximizes the power dissipated basically. Okay, so from our previous part, we had this as our power dissipated. Now what we want to do is maximize this. So we're now going to use the hint they give us there. They tell us to minimize 1 over P because that will maximize the value of P. This makes sense. Let's call Y to be 1 over P. So 1 over P is in fact just R1 plus 2R3 squared over V squared R3, which is the same as 1 over V squared multiplied by R1 squared plus 4R3 squared plus, so 2 times 2 plus 4 R1 R3, everything divided by R3. Okay, so this is equal to, so let's go ahead, is equal to 1 over V squared into R1 squared over R3 plus 4R3 plus 4R1. Okay, now what we need to minimize is this expression here. Okay, so let's go ahead and differentiate that. So dy, so we do dy by dr3, because R3 is a variable here, is going to be equal to 1 over V squared, so 1 over V squared into, so R1 squared. Now if we differentiate 1 over R3, we're going to get minus 1 over R3 squared, so we get an R3 squared here. If we now differentiate next term, which is 4R3, we'll just get plus 4. If we differentiate 4R1, we'll just get 0. So now we differentiated this. Now to find the minimum value, so the stationary points, we set this equal to 0. Multiply through by V squared. What we get now is just that minus R1 squared over R3 squared is equal to minus 4. Therefore, R1 squared is equal to 4R3 squared. Therefore, R3 squared is just equal to R1 squared over 2, and R3 is equal to plus or minus, this is supposed to be a 4, R1 over 2. Now, negative resistance does not make sense, so the only solution here is going to be R3 equals to R1 over 2. Therefore, the answer is B.